All right, we're back. We're on page 7 of Calc AB Notes 15, and we're doing limits of Riemann sums to find the exact value of definite integrals. I'd just like to point out the grammar of one of these sentences is atrocious. I noticed it while I was waiting for things to start. So, okay, here are 3 more to work out. That's fine. After writing the limit with the summation, box it and think about it. Make sure what is happening there? Okay, so what I think should be happening is after writing the limit with the summation, comma, box it and think about it, period. Make sure you really understand each part of it before you move on. I think that that's what it should have said. And will I change that? Probably not, but be aware I am as critical as you are of the quality of these notes. I'm probably more critical because it seems rude to be as critical as I am if I didn't actually write the notes. So we're gonna go through, we're gonna do these, I wanna say as fast as we can, but I know that's probably not gonna happen. Also, it would seem to be implied that we should do them in columns, but I'm not gonna do that. Also, if I was gonna do them in columns, why did I make them formatted like this instead of all the way across? You know, if I remember, I am gonna go in and fix this page a little bit, but whatever. All right, let's do it. Delta x, first step. 4 minus 2 over n is 2 over n, x sub I, 2 plus 2i over n. So we are doing a of n from 1 to n of, okay, so it's x sub I, 2 plus 2i over n squared plus 2 times 2i, nope, 2 plus, there's too many 2's, minus 1. All right, that's just f of x, and then we need a delta x, 2 over n. Okay, so I'm going to take out the 2 over n, just doing the things we usually do, right? So these are very much like practice at this point. You should kind of know what you're doing. Multiply them together is 4 times 2 is 8i over n plus 4 squared, like that. And then distribute. Oh my god, everything looks the same. Okay, what collects? 4 minus 1 is 7. 8 plus 12i. The fun part is when you get them wrong and then you get to go back and figure out where. We saw last time what the most common place is when you have the sum of I squared. Everybody forgets that 2 that's just hiding inside as a factor. I forgot it, obviously. So 2 over n. And then it's 7 and n plus 2 over n, 12 over n, and then n plus 1 over 2 plus 2. So I'm trying to write it out so that potentially I could go back and highlight some stuff. If the spirit moves. I read a really good book a couple years ago called, I think it's called The Spirit Moves and You Fall Down or something like that. It was really good. It was about it was nonfiction, and it's kind of about the intersection of modern medicine and traditional beliefs, I guess. I think it's The Spirit Moves You and You Fall Down, maybe. Really good. If that's the title, I recommend it. So we're going the integral from 2 to 4 of x squared plus 2x minus 1, and then dx is the limit as n approaches infinite. I'm just going to say of a of n, right? We named it a of n way back. And then this we can more or less do in our heads, I would say, because this is 14 n over n, so just 14. This is 2 times 12 over 2, so just 12. This is the one that got me last time. This is 2 times 4, and then over 3, because those cancel, so 8 over 3 is, I don't know, 26, 60, 78, 86 over 3, I think. I made this 26, and tried to triple that, which would be 60 plus 18, which would be 78, and then plus 2 plus 6. I think it's 86 over 3. We will check that on a calculator. So the next one, where am I putting it? I'm putting it below. Okay. The integral 3 to 7. Let me write it. That's not a marker. Okay. The integral from 3 to 7 of 3x plus 5. If that's not the right problem, that's the problem we're doing. So deal. I'm going to say delta x is 7 minus 3 over n, 4 over n. Because I'm assuming you're just watching this for practice. Like, you can do these on your own. You don't really need me. But if you do, you know, that's what we're doing. So 1 to n, all right. X sub 3 times x sub I is 3 plus 4i over n, and then plus 5, and then all of that times delta x. This one seems easier. 4 over n, 1 to n. So we get 3 times 3 is 9 plus 5. It's 14 plus 3 times 4 is 12. Yeah, I think we're doing all right here. 48 over n squared, n plus 1. I mean, I'm going pretty fast, so I could imagine getting it wrong. All right, so this thing is what we were trying to find. And I'm just going to say it equals the limit as n approaches infinity of a of n. And so depending on your teacher, depending on the course you're in, you might have to show more work than what I'm showing. I'm okay with this amount of work. 70, 80. This one's a trapezoid. So like, I mean, you can check it potentially. If I plug in 3, I get 14. If I plug in 7, I get 21, 26. So this is going to be 2 times 30, 40, 2 times 40. I think it's right. Okay, one more. 0 to 2 of x cubed. X cubed. That is not great. But so 0 is a super good starting point. So this, I mean, it might not be that bad. 2 minus 0 over n. So we don't do cubes very often because, like, they're annoying. I mean, that's really why. Especially like here, we're lucky with x sub I. It's going to be 0 plus 2i over n. So like the 0 plus is just 2i over n. So it's easy to cube it. If it was like 5 plus, what a pain in the neck, because now you got to like cube a binomial essentially. So a of n from 1 to n of, so we take x sub I and cube it, and then we multiply by delta x, just base times height. And then this is 8i cubed. Nope, 8 times 2, 16i cubed over n cubed times n to the 4th. So this is okay. We haven't really seen it before, but it's not a problem because the sum of I cubed is, if you can remember the sum of I, which is n times n plus 1 over 2, the sum of I cubed for whatever like cosmic reason is the square of that. So it's n squared n plus 1 squared over 4, right? So it's like n plus 1 over 2, but then square the whole thing. That gives you the sum of I cubed. That's magic right there. I'm not going to do anything with that. And then, so this is going to be the limit as n approaches infinity of this, duplicating, of this. And that is 16 over 4. It's 4. crazy if it is. So let's go to the calculator, type them in, and just see if we got them right. I hope we did. Also, this mic no longer shows if it's working or not, and it is the most frustrating thing. So I muted myself and I unmuted myself, and now it shows that it's working. I hope it's working the entire time because, like, I'm not re-recording these. Oh, are we already on the calculator? I think we are. Jeez, that was fast. All right, I'm gonna type them in the way they were given, which is like obviously the fastest way to check them. Ooh, 2 to 4. X squared plus 2x, give me an x, minus 1 dx, 86 over 3, we got it, woo! The next one we checked geometrically, so like I'm pretty sure we got it right on paper. It's really a question of did we do the right problem. And then this one had like a really nice answer, 0 to 2 x cubed dx was just 4. So we actually got them all right. So good job us. You know, practice makes you better. But as you saw in the previous video, I still got one wrong and I made the most common mistake. So like practice makes you better, but like thoughtful practice makes you better than that. So now all of these worked out, but they were polynomials. And so because they're polynomials, we're able to use these summation formulas that we have memorized. What in the world are we gonna do if our function is like sine of x, right? We could still set it up, but then you run into this problem where you're trying to find like sine of 2 plus I delta x. Like what in the world do you do with sine of 2 plus I delta x? So we need something better than that. We're gonna find something better than that because like honestly, do you think you wanna keep doing all of this work all of the time? Like I don't think you do. So I'll be back in the next video and we're gonna talk about a better, is it better? Yeah, kind of a better way of doing these. So a more direct way of doing these. So I'll see you in the next video when we talk about that.